All we have to learn today is synthetic division, so even though it's pep rally schedule, I'm going to warp through 1 through 4 pretty quick. I'm not going to ask you guys. I'm not going to go back and forth because I want to make sure we have it done. Okay? So you guys were supposed to do 1 through 4 from side AB as quote-unquote homework. It's not graded. It's part of your notes. So we're supposed to practice our long division, so make sure, Jaden, that we're paying attention and not on our phone. Okay? So if you didn't do it, make sure you follow along. I will give a pause at the end of each one to give you a chance to copy. I'm going to reiterate, and I'll say it again probably after break. I'm going to reiterate that when I'm writing and I'm just talking and going is the time for you guys to be listening and paying attention. It's very difficult to write what I write and pay attention to what I'm writing at the same time. So I'll always pause and give you guys a chance to write it. So it behooves you to listen and not write simultaneously. So x squared divided by x is x. Distribute. X squared minus 3x, subtraction sign, parentheses. X squared minus x squared. Negative x minus minus 3x, that's negative x plus 3x. 2x, bring down the negative 6. You're going to go in twice because 2x divided by x is 2. Distribute. Subtraction, parentheses. Those both cancel. No remainder. The answer is just x plus 2. Yes? So did Tim. I don't know why. Yeah. Alexa? Okay. All right. Side C is always just the same. It's the same concept, just a little harder. It just prepares you more for the homework, you could say. So number 1, guys, we didn't go any questions like this. This is a key concept. One of the questions in your homework and on it is going to be, is the divisor a factor? No, not while I'm going. As soon as I'm done. Is the divisor a factor? If the remainder is 0, the answer is yes. If the remainder is not 0, the answer is no. So here, is x minus 3 a factor? Yes, because my remainder was 0. It's a very basic concept, okay? So, yeah, correct. Any questions on number 1? All right. So number 2, x minus 5 going into 2x cubed minus 10x squared plus x minus 5. Okay, 2x cubed divided by x is 2x squared. Distribute. So here, Josiah had a question about this. Both of these cancel. You need to have as many terms as you have here. So don't just drop the x. You need to have, this has 2 terms, drop both terms, okay? So drop the full x minus 5. Drop them both so you can have something. X goes into x once. Distribute, subtract, parentheses. And once again, we get.
Isn't it? Never mind.
That's twice now. This is a factor. So x minus 5 is a factor of blah, 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 the whole thing.
Where's the 1 from?
This one?
Yeah.
So x divided by x is 1. So you're always looking at the first one. So I did 2x cubed divided by x is 2x squared. X divided by x is 1. Yes? What do you mean? Here? No, on the workbook it is for some reason, but on our notes it wasn't. And in your homework it's not. I don't know why the workbook only does it with x. Now, when you do synthetic division, which we're going to learn today, that will always be a binomial with the power of 1. Yeah. 3 and 4. And juniors, I don't know how many juniors are in here. Most of you guys are juniors. I apologize. I totally forgot to wear red today. That's on me.
Why do you have to
It's pep rally. I know, but I like to rep you guys. I like to rep juniors. Huh? Because I don't know, just something about juniors. Yeah. Oh no, I don't count things like that. That's only lame people. This is one of the few classes that I had quite a few of them as freshmen and as sophomores and as juniors. So since I've had them, I'll have had them like 3-4 years in a row by the time they graduate. You know. So that's why. Anyhow. I don't know if these actually got any more difficult, but negative 3x squared divided by x is negative 3x. Distribute. Subtraction parentheses. Cancels. 20x minus 18x is 2x. Drop the 12. Multiply by 2, yeah. 2x divided by x is 2. Distribute. Subtraction parentheses. So we seem to get factors. Does number 4 end up being a factor also, those of you who did it? No remainder on number 4? Martina, was there a remainder on 4? Okay, cool. So let's do it then. Huh? Okay. So x plus 3 going into 3x cubed plus 9x squared plus 0x minus 14. I put my placeholder in so everything lines up. 3x cubed divided by x is 3x squared. Distribute. Subtraction parentheses. Cancels. Bring down 0x minus 14. It doesn't go in, so all that's left is 14. So right, so I could put plus 0, but that's not really necessary. So here's my remainder. So it's going to be plus a negative 14 over x plus 3. That one had a remainder, thank goodness. Dylan.
What if you can't, like, go into it at all?
It can't. That's what happened. I have a remainder.
I know, but, like, what if you had a problem where you can't go into it?
Oh, then you wouldn't do it. That's all. That's all there's to it. Yes?
Should you put the 0x because of the x plus 3?
Because it goes power of 3, power of 2. The next one should be power of 1, but it's missing. Alexa.
How do you get like the number on top again? Like I know how to do it, but it's like
It's the remainder.
no. 3x squared. Because it's like
Oh, it's the first term divided by the first term. 3x cubed divided by x is 3x squared.
oh, okay. So you in that case you would just subtract
Yeah, you subtract the exponent off.
because exponent
Yeah.
add them up to subtract. Okay.
Right. Okay, synthetic. You guys familiar with synthetic division with binomials?
What?
I'm asking the exchange students. Synthetic division? Yes, no? See? No? Okay. All right. So let's you're just reading the example. Then we're going to do them in the workbook. You're just reading the example, and then you are going to do them in the workbook. So our example in our notes is x cubed plus what? 4x squared? Divided by?
In our notes or workbook?
Notes.
Oh. I know you
Notes.
said workbook.
I apologize. So you guys are just going to follow along.
Yes.
I want you guys to understand that. I've written out the entire steps of the problem, and it probably looks crazy. Once you see what we're doing, it won't be. I wanted to have it typed out for you because I wanted you guys to not have to, like if you write it yourself, I don't know what it's going to look like, and you might confuse yourselves. So I wanted one where it's nice and typed out and you can do it. So the first thing, I'm going to tell you where everything comes from. We have a little box, and in that box goes negative 3. Okay? That is because we're checking x plus 3. But what do we do when we finally solve a problem? What do we do with what's in parentheses?
It's
It's opposite, but what are we doing to get it to be opposite? We're not just changing the sign. I don't want a rote memorization here. Remember the barn problem? What did x end up being if you remember the barn problem?
Oh, wasn't it x minus 10 because you took away the 2 sides?
No. What did x end up being when we solved it out?
Oh. X,
Equals
-3.
16. Careful. X equals 16 was the answer to the barn problem because one of the parentheses was x plus 16. Or sorry, x minus 16. So we took that parentheses, we set it equal to 0.
So it'd be
We
negative
set it equal to 0. One in a full sentence, okay? I know you said the word 0, but that's all you said. That's not a sentence, okay? So right here, the reason why this is a -3 is because we're saying x plus 3 equals 0, so what are we letting x be? X must be -3. So we're saying what x is when we put a -3 in that little box, okay? That's why. If I'm not going to be able to call you on it, if you just stick in your mind, got it, Mr. Bates, you just put the opposite sign. That's not what I'm saying, but if that's what you're thinking to yourself and that's what you remember, that's on you, okay? Now, over here, I'm going to put the coefficients of every term, and if I need a placeholder 0, I have to put it in this time. But in this case, I don't. In front of the x cubed is what number? 1. In front of this? -5. Okay. So, the opposite sign of that, in the little box, every coefficient. We're good, yeah?
Yeah.
All right. Now, we're going to give ourselves a little bit of room, put a line. We always bring down the first number. We always bring down the first coefficient. Okay? Then, the algorithm, the pattern, is -3 times 1 is what? That's what I put there. Then I add 4 minus 3 is? -3 times 1 is? -3 plus -3 is? -3 times -6 is? -5 plus 18 is? Okay? Multiply, place it, add. Multiply, place it, add. Multiply, place it, add. Okay? Now, this is called the depressed polynomial. I have technically divided x to the third plus 4x squared minus 3x minus 5. I've divided it by x plus 3. It is this. These are my new terms. But if I divide x cubed by x, what will it be? X squared. So this is 1x squared plus 1x minus 6. I'm out of it, so this must be my remainder. So plus 13 over x plus 3. That's it. So this did the exact same thing you did with long division, but it takes out all those letters and it goes like that. Aaron? Where did you stop looking at? Huh? The -3? Huh? You gotta speak way louder, dude. Oh, so it's -3 times 1, got me -3. Then I add 4 minus 3 is 1. -3 times this one is -3. -3 plus -3 is -6. -3 times -6 is 18. -5 plus 18 is 13. That's along the whole right side there, if you didn't see it, of the notes. So then, Aaron, everything dropped by a power. My original one was x cubed, so all of this represents an x squared. So it's 1x squared, 1x minus 6, and this is my remainder. It goes over my divisor. Patricia. What?
Why is 13 the remainder?
Because I'm out of exponents. So if I'm going down, I've got x squared. I have x to the 1. Then I have basically x to the 0, but now I'm out. I'm out of anything. So this must be my remainder left over. So that last number will always be the remainder. If this ended up being 0, what is this then? if this ends up being a 0, what is this?
Factor.
It's a factor. If this ends up being 0, there's no remainder, so therefore the divisor was a factor. Okay?
And then you got
One more thing, and this is the note at the bottom. Way back in the day, so I'm going to put a more complicated problem up with uglier numbers. Okay? I'm going to put a more complicated number up with uglier numbers. So, if I said 14 x to the 4th minus 3 x to the x cubed plus 7x squared plus 5x minus 8. I don't know. And I asked you for in Algebra 1, and this, let's say this was f of x. Okay? And I said, oh, this is just the function. And then I said, what's f of 6? What would I do? Yeah, I'd go 14 times 6 to the 4th minus 3, 6 cubed plus 7, 6 squared plus 5 times 6 minus 8. And I'd have to solve that. So I'd get 1,296 times 14 minus 3 times 216 plus 7 times 36 plus 5 times 6 minus 8. And then I'd have to solve all that, right? And it sucks. Right? Especially, I mean, the big thing that sucks is 1,296 times 14. I don't want to do that. Right? You guys are reaching for calculators at that point. Right? So, what I could do. This is called synthetic substitution, and it is the exact same thing as synthetic division. So if I wanted to find out what f of 6 is, I could go 6, 14, negative 3, 7, 5, negative 8. That sucks, but it's not 1,296 times 14. So I could go 6 times 14 is 84. 81. I mean, it's still big numbers. 486. 493. 2,400 plus, it's almost 6. So that's 3,000 minus 42. So that's 2,958. Like I said, still sucks a little bit.
it's not as bad as like the
Right.
bigger numbers.
Right. So I'm going to stop here, but you guys get the pattern. Multiplying, adding. I'm not going to finish it off. I don't feel like doing this one right here personally. But it will be the same answer. If I were to substitute 6 into this, it'd get the same answer, but this is so much faster.
And since you don't have the divisor, you can just
Right, it's not. This is not dividing anything. It's actually substituting it in. So synthetic division with a binomial and synthetic substitution are the same thing. So let's go ahead. Get out your workbooks. We're going to do 5 through 8, or 5 through 9. Yeah. We got lots. I felt like you guys, for the most part, were really latching on to the, we're doing 5 through 10. Oh, we're doing 5 through 12. But we'll start with 5 through 8. We'll do 5 together. Then I want you to try 6. We'll do 5 together. So what on number 5, what goes in my little box? 2. Then 3. Negative 8, careful. 4. Bring the 3 down. Okay? 2 times 3. Negative 8 plus 6. 2 times negative 2. Negative 4. 4 plus negative 4? Okay. So this is a factor. I've divided it. So this was an x squared, so I've dropped a power. This is a x. I'm done. Tell me that's not easier than long division.
that is
But it only works with binomials with exponent 1. It only works with binomials exponent 1. There are tips and ways to get it to work otherwise, but that's what we do. Dylan.
So like it only works if it's like x minus.
Or plus something. It could be like 3x minus or plus something. It can have a coefficient on the x as well. if let's say it said blah 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 divided by 3x minus 2, right? Then you would remember, and this is why it's important to not just think opposite sign in your head. What do I do with it, Dylan? How did I get the opposite sign? Yeah, set it equal to 0. So I'm going to add 2 and then divide by 3. So in my little box would be 2/3. You know? But at our level right here and right now, that's not going to be a thing. They might do it for some of the extension questions on the homework, but. All right, you guys do number 6? Probably not on a quiz or test, okay? She asked if I'd do like a fraction in the box on the quiz or a test, and I said probably not. There's a good chance I wouldn't. Did you guys do number 6 already?
Yeah, I'm doing it right now.
No, I'm talking to the people who are talking.
I need a calculator. Leticia, can you get me a calculator?
When we're done with these problems. It'll be right at the end of the period. Negative 15 is correct? Yeah. Yeah. It's the same thing. It's right. So negative, right? So negative 15. Then you did negative 3 times negative 19, right? And you got 58. 57. I mean, sorry, 57 plus 12, and so 69 is the remainder. So it'll be plus 69 over x plus 3. So the problem was, like Aaron was pointing out, that would be it's a negative 3 in here because of the fact that it's x plus 3. So this would be a negative 3. And then negative 3 times 5 is negative 15. So, and then negative 3 times negative 19 is positive 57. So, opposite sign of that x plus 3, we put a negative 3. Negative 3 times positive 5 is negative 15. Add those, I get negative 19. Negative 3 times negative 19 is positive 57. 57 plus 12, we have 69. Okay, this is dropped a power. This is x squared, so this is x. So we have 5x minus 19. We have a remainder. If you guys watch me do it, if I didn't do it while I'm showing you the examples. But if you guys watch me do it, if I were to do it on my own paper, just on my own, I tend to put like a line right there, so I always know that's my remainder. It just helps me do it. It's like a little thing that I do. It's a reminder for my remainder. Ooh. Okay, so this is my remainder, so I'm going to put plus 69 over the divisor, which is x plus 3. Samuel? You good?
I mean, I did number 6. Did you even go to that?
Huh? Oh.
That one's number 6.
Yeah.
I definitely did number 6.
Let's do 7 together, and then you guys can try 8. So we put a 1 in the box, 9, negative 7, 3. Drop the 9. 9 times 1 is 9. I gave myself an easy one. Negative 7 plus 9 is 2. 1 times 2 is 2. My remainder is 5. So my answer is going to be 9x plus 2 plus 5 over x minus 1. You guys give number 8 a shot?
What'd you get?
Yes, under the remainder.
It's the same thing.
It's the same thing as under the parentheses for the remainder. Yeah. Because the remainder, the denominator of the remainder is always your divisor.
I like this one. 'Cause I know how to do this.
So have you guys seen this before? Yes, no? No. Just checking. Josiah? The remainder is what it is. If you that you should have a remainder. I mean, you shouldn't always. You could have 0. It's fine to have 0. But in synthetic substitution finds that if I were to plug this number into the polynomial, what do I get? It's telling you what you'd get. The remainder is your solution. In synthetic substitution, the remainder is your final solution. F of 3 equals 11, yeah.
Did we do 9, 10, 11, 12?
It's 47, not 37.
Madeline, we have homework tonight, so make sure. Well, over the weekend. I'm not going to expect it tomorrow.
Okay, is it a paper?
No, I don't have. It's on the. It's in the book. Yeah. I didn't do a printout. Okay. 50. Okay. All right. So Yvonne, you got -6, right? Of course. -6 times -7. 42. 42 plus 5. 47. Then you had to obnoxiously multiply -7 times 47, and you got -329. Add those. And you are correct. So it's -6x plus 47 plus -339 over x plus 7. All right. All right, folks. 9, 10, 11, and 12. You're literally doing the same thing. It's just rephrasing the question, right? So 9 and 10 are doing synthetic substitution. So find what the value is for when x equals. Since it says x equals already, we're not putting opposite signs in. It says x equals, so we're not putting opposite signs. So for number 9, we've put a 3 in the box for -9, 2. And the solution is going to be whatever the remainder is.
Wait. Also, unlike the other one where we're finding why did you get just minus?
Where did you get 6?
3 times 3 is 9.
3 times 3 is 9.
Oh.
I was like,
Up. Yeah. That. My mistake.
what?
My mistake there. Sorry. I just couldn't multiply.
The remainder would be, just p equals whatever.
Yeah. And
How is the remainder?
really quick, guys. So this is showing you. I'll give you guys 30 seconds, and then I'm going to expect pencils down. I said 30 seconds, and then pencils down. Wait, yeah. Okay, Michael. Yeah, let's get some good multiplication in here. Or actually, Tim. I'm calling you much. Okay, this is just saying, if we substituted 3, what would we get? Tim, what's 3 squared?
3 squared?
Mm-hmm.
No, it would be 9.
9. What's 9 times 4? 36. Does everybody follow me so far? I plugged in 3 to there. I got 9 times 4. Tim said 36. Tim, what's 9 times 3? 27. So I get 36 minus 27. Tim, what's 36 minus 27? 9. So I'd have 36 minus 27, which is 9, plus 2, 11. Much faster. Right? Dylan, did you follow that? I said if I actually plugged in 3, it's saying find if I substitute in 3. Well, 3 squared is 9. 9 times 4 is 36. Minus 9 times 3, that's 36 minus 27. 36 minus 27 is 9. 9 plus 2 is 11. I get that. That's fast. Yes? Yes. Yes, it's the remainder. Okay, number 10. Guys, if you haven't done it, we have -2, -3, 10, -4, 6, there it is.
For the answer?
I did this too.
Okay?
Did you study putting it in the free?
Okay.
Time-wise, I'm just because I want to get your old papers back to you. Malika's gonna pass them out in just a second. Here, determine whether it's a factor. It's the same thing. I just want a remainder of 0. So I'll put a 4 since it says x minus 4. It doesn't say x equals 4. 4, and then 1, 8, -48. Here's number 11, right? 1, 4, 12, 48, 0. Yes. I got 0. Yes, it's a factor. Okay? Because they're ridiculous. I'll try to squeeze in 12 right up here. -5, 2, -6, -1, 2, -10, no, nowhere near. Right? So that's 80. No. That's not a 0. That's it.
I like this one.
Yeah. So you guys have homework. It's 1 through 20 due Monday. Oh, so remember, and make sure you guys tell Madeline and Sydney if you get the chance. I mean, it doesn't matter if you don't, but for it to be nice, we'll have a quiz Monday on all of Module 6. That's 5 sections. Guys, I'm just going to pull questions from the homework, which is why it's important that we get this passed back to you, because I want you to have some study material. You want to? Monday review, Tuesday quiz, Wednesday, Thursday, Module 7. I could try.
I just didn't know if you remember tomorrow's.
I know it is. That's why. So. Oh, okay. Guys, be prepared for a quiz on Monday. If I end up figuring out how to shorten up Module 7, then maybe I'll do a review day Monday instead. Be prepared, and if there's no quiz, be thankful, and if there is a quiz, just be ready for it. Module 6. Amanda, make sure you double check these to see if it's one that Alexa?
The girls, they love me, so I went to the mall. They were so excited because it was their first time in the mall without an adult. Oh, really?